For exercise number 29, chapter 7, section 12, we are given this piecewise function and we're supposed to solve it in two different ways, the cosine and with the sine. So what we're going to do? Well, first of all, we want to use equation 12.15 and start from GC of alpha in this case. So it has to be from negative infinity to infinity of f, actually sorry, well it says that from 0 to infinity, correct? So fc x cosine of alpha x dx. So now I have to break this in three pieces because of course we have three boundaries. So we're going to have from 0 to 2 of, what is f of c? It's going to be -1, so -1 cosine of alpha x dx plus the integral from 2 to 3 of, in this case, it's going to be 1 cosine of alpha x dx plus the integral from 3 to infinity of 0 cosine of alpha x dx. Let's make things easy. This one is going to be equals to 0 directly. Let me do another color. This one is going to be equals to 0 quickly. So we can just simply focus on the other two. So from the first one, we're going to get that it's going to be equals to negative the integral from 0 to 2 of cosine alpha x dx plus the integral from 2 to 3 of cosine alpha x dx. So here we're going to get the integral will be equals to the sine, negative sine of alpha x over alpha from 2 to 0, and then plus the sine of alpha x over alpha from 2 to 3. Okay, so now we're going to solve it. First one, we're going to get sine, negative sine of alpha x, x is going to be equals to 2 over alpha minus, well, that's going to be equals to 0, actually. So we're going to get minus 0, sine of 0 is equal to 0. I'm just going to write plus, actually. Plus sine of 3 alpha minus sine of 2 alpha all over alpha. Okay, so I'm going to put this together. We're going to get sine of 3 alpha minus 2 sine of 2 alpha over alpha. Then, with this, since this is equal to g s of alpha, we're going to find, gc, fc of, the thing is that this is only equals to the first, this is equals to the full thing from 0 to infinity. So fc of x is going to be equals to, one thing that I forgot to write was the square root of 2 over pi in front. So it's actually going to be in front of everything. Okay, and here we shift that. Square root of 2 over pi. So fc of x is going to be equals to n square root of 2 over pi integral from 0 to infinity of g of c, so this part right here, times the cosine of alpha x dx. Okay, so I'm just going to take out the constant to make it look better. It's going to be equals to, well, square root of 2 times square root of 2 is equals to 2. Then I'm going to have pi squared No, actually, sorry. I completely missed out on this. Square root the whole thing. So it's going to actually be equals to 2 over pi, not square root 2. Okay? And then the integral from 0 to infinity of this part over here that I'm not going to integrate because it's kind of pointless. Alright, this is the final answer for our problem, for part A of our problem. So for the cosine, said for the sine, so let me do it like this. For part B instead, we're going to have to use the sine, so when it's going to be equal to an odd function. So same thing, g, c, times of alpha is equals to square root of 2 over pi, integral from 0 to infinity of f c x, sine of alpha x dx. Oh, actually here it's going to be equals to d alpha. Okay. Alright, so here, then we can substitute it and we're going to have 3 intervals again. The last one is always going to be equals to 0, so I'm just going to avoid writing it. Square root of 2 over pi, and then integral from 0 to 2 of negative 1 sine of alpha x dx plus integral from 2 to 3 1 sine of alpha x dx. So when we solve this, we're going to get square root of 2 over pi, and then times what's inside the parentheses. Well, it's going to be equals to negative, and then the integral of sine is going to be negative cosine, so it's going to be positive cosine of alpha x over alpha from 0 to 2 plus, and then actually going to get minus here, cosine of alpha x over alpha from 2 to 3. So solving it, we get square root of 2 over pi times cosine of 2 alpha minus 1, because cosine of 0 is equals to 1, alpha minus, then we're going to get cosine of 3 alpha plus cosine of 2 alpha over alpha. So solving this a little bit more, we're going to get square root of 2 over pi, and then 2 cosine of 2 alpha. Oops, sorry, this one is actually going to be equals to positive here, then negative here. Oh, okay. Minus cosine of 3 alpha minus 1 all over alpha. So f c over x is then going to be equals to the square root of 2 over pi integral from 0 to infinity of g c of x, sorry, of alpha, cosine, not in this case we're talking about sine, so sine of alpha x d alpha. So it's going to be equals to, oh, I rewrote the mistake here. So square root of 2 over pi integral of our g from 0 to infinity, that was this part right here, sine of alpha x d alpha. So multiplying the constant, so just the first two, is going to be equals to 2 over pi integral from 0 to infinity of what is left right here. I'm just going to try to avoid the first parentheses. Okay, and that will be the final answer to our problem. That's going to be equals to, oops, f of x. Well, actually f c of x, but that's going to be the final answer to our problem. And then this is part Oops. Okay. And that is the end of our problem, as you can see. Didn't take long, just a little bit of practice.